We spent a lot of time in earlier modules calculating measures of center, measures of spread. So in this case, we're now going to look at a measure of center and a measure of spread, specifically the mean and standard deviation, because it's connected to what we call a continuous random variable. And we're going to look at the distribution, right? The probability of the outcomes of certain values for a quantitative variable. Now, I've used a lot of complex language and I'm going to continue, but let's hopefully we'll simplify this for you. We start by formally introducing you to what's called a probability density function. It looks like this kind of curve here, this complex curve. What it turns out is when we know the mean and standard deviation for a variable, and the outcomes are continuous, meaning that we have an infinite number of outcomes potentially, how can we calculate the probability of an outcome when there's an infinite amount? And that's what this allows us to do magically. And it comes from the world of calculus to do that. So what happens is we calculate the area underneath this magical curve here that we call the normal curve or the normal distribution. Now, and the density part has to do with the area. Density has to do with space inside of something. And so that the area beneath the density curve is equal to relative frequency or to the probability. That's something that we're going to, again, it comes from the world of calculus, but the idea that if I could calculate the area underneath those curves, and we do not do that, ArtistStat will do that for us, that we now know that the area is directly connected to probability or the percent or proportion of some outcome. Now, we're going to hear this term in statistics. Oh, what's the area underneath the curve? When you hear that, we're just talking about probabilities. When we talk about density graphs or area underneath that, we're talking about the probability of a quantitative variable occurring. What's the probability of something happening if we know the mean and standard deviation for that variable? And the first distribution we look at, or the one we focus on in Chapter 7, Module 7 and Module 8.2, is what we call the normal distribution, right? That's the symmetric unimodal shape, right? That bell-shaped, or we call it normal curve, bell curve, right? So that's the thing we had studied previously, but now we're going to analyze it from the perspective of calculating probability. The first big idea in the title of the section is called the empirical rule. What we learn is this, and this is how we're going to calculate probabilities. When we have something that's normally distributed, and this has happened over and over and found in our world in many ways, when we collect data and we calculate the mean and standard deviation, and the data is normally distributed, right, has that bell shape, what we know magically is that if I have the standard deviation, we can then determine a certain percent. We can know within what values, right, the normal range of values, the outcomes will occur. And so we know 68% of the outcomes will be within one standard deviation of the mean. And that's what this kind of complex stuff is. Within 2 standard deviations, 95%. And then if something's within 3 standard deviations, it's a 99.7% chance, or that all the data is within 3 standard deviations, almost all of it. There's just a little left, 0.3 left over, 0.15% on each side of 3 standard deviations. So this goes back to the conversation of unusual, right? Or do we observe something's unusual, 2 standard deviations, right? The 5% rule and so forth. And so what we have to consider, right, when we think about is this mean and standard deviation. And what we do is we connect this thing back to z-scores. And so keep in mind, remember, z-score measured how far above or below you are from the mean. And a z-score of 0 represents your average. You're right in the middle, kind of in the center. And so the standard normal distribution looks like the same thing here, but it's our discussion when we're looking at the z-scores, right? And we can then calculate what's the probability someone has a z-score of 1 or 2. That's called the standard normal distribution. The mean is 0 and the standard deviation is 1. And so the empirical rule looks like this here. 68% of all values are between 1 standard deviation, 1 less and 1 above, 95% and 99%. And so we can answer a question like this. And again, the empirical rule is an approximation because we're going to then use the calculator to get the exact precise. But many times we just care about the approximation, about how many. So another way to see our z-scores is here, where you can say, what's the probability that someone's z-score is between -1 and 1? 0.68. Between -2 and 2, 0.95. Between -3 and 3, our z-score, 0.997. Almost all of the data is within 3 standard deviations, and that's called the empirical rule, or the 68, 95, 99.7 rule.